All right, people. So, last lesson we looked at just basic probability models and some notation. This lesson we are going to actually go into stuff that for some of you, again, may be sort of new. Hopefully we can kind of look at this with new eyes if it is not new. But here we go. So today we're going to look at two-way tables, which we looked at way at the beginning of the year. And then we're also going to look at Venn diagrams, which every adult loves to have you create Venn diagrams. I know, I feel like in English, you guys make Venn diagrams to compare and contrast and blah, blah, blah. So we are not going to be, you'll see. Venn diagrams, basically, in my opinion, are sort of dumb and useless. You might disagree with me, and that's totally okay. Lots of people do. But as you're going to see, Venn diagrams are sort of annoying mathematically in a statistics setting. So here we go. So we're going to look at a problem, and we are going to construct a two-way table to model this data, and then our main spiel is we're just going to answer a ton of questions about probability. So here we go. So example 1 says, a recent survey asked college students if they had pierced ears. They also recorded the gender of each student. Here are the results. There were 178 people total, 90 males, 88 females. 84 of the females had their ears pierced, while 19 of the males had their ears pierced. And then part A, they would like you to construct a two-way table to model this data. All right. So I like to think of these problems as sort of, they're almost like Sudoku, if you will. And I'll kind of explain why in a little bit. So first of all, we got to look at the information they're giving us, because in a two-way table, as the name suggests, they should be telling us information about two different variables. So one of our variables, it looks like, is whether or not these people had pierced ears, and the other variable appears to be gender. So we are going to create a table that shows pierced ears and gender, those two variables, and within those variables should have categories. So for example, I'm going to go ahead and put ears pierced on top. And basically for ears pierced, either a person does have their ears pierced or they do not. Okay. And then as far as gender goes, we're going to assume simplicity here. We're going to assume that you either have male or female. Okay. So I have ears pierced and I have gender, male and female. And then you may or may not remember this, but in a two-way table, we also want to make sure we have spaces for the totals on each section. So that is how I'm going to start to create my two-way table. Next, I'm going to take the information that they're given to me, or that is given to me, and I'm going to fill in as much as I know from the two-way table. And then after I do that, I will solve for what I don't know. So off to the side here, I'm going to put create table with the two given variables, and they will give you variables. Oh my gosh. That's kind of step 1. Step 2, which we're going to do right now, is we're going to fill in given values. They very rarely will give you all of the values in the table just because it's really annoying to list them. So let's talk about what they do tell you. They tell you that there were 178 people total that they interviewed. So the absolute total should be 178. They told you that we have 90 males and 88 females. And then the only other two pieces of information they said were that 84 of the females have their ears pierced. So I would go to yes, ears are pierced and they are female. And that 19 of the men had pierced ears. Okay? And then finally, what I'm going to do last is I'm going to solve for what I don't know. So solve for unknowns. Okay. So everything they've given me so far is, given. It's done. So now I'm going to write in the things that are not given, but that I can find. So for example, I can find the total number of people who do have their ears pierced, which if I add these together, I should get 103. Okay. Then I can kind of keep going. So for example, males, I should have 90 males total. If 19 of them have their ears pierced, then I would just need to subtract that 19 from 90 to get how many are left over in the no category, which should be 71. And then here, 88 females total were interviewed. 84 of them have pierced ears, which must mean 4 are left over who do not have their ears pierced. And then finally, the total for no, I would just add these up, which should be 75. Okay, so that's why I sort of say it's like a Sudoku of sorts. So a lot of times you might be asked to construct a two-way table. This is sort of the process for doing that. Once you have this two-way table, now they're going to ask you questions about probability. So let's talk about probability as far as this goes, because it's a little abstract, so hear me out. They have collected a bunch of people, and some of them are male, some are female, some of them have their ears pierced, some don't. And so basically the way you want to think about this is out of all 178 people they interviewed, they're going to select one person at random. And so the way I think about this is, okay, I have selected a person at random. I have this random person in a box. And so they're going to ask me questions about this person that I have in said box. So I'm going to select a random person. I have a person that I'm putting in a box. Why the box? I don't know. It helps me visualize this. And so they're going to ask you things like, what's the probability that this person is male, let's say? Well, that would just be the probability of being male, which would be how many males there are out of how many total. So 90 out of 178. They might ask me, hey, what's the probability that the random person in a box has pierced ears? In which case you'd have 103 out of 178. So the way this works with a two-way table is think of it like you have your total number of people. They select one person from the group at random, and they're going to say, what's the probability that this person is? And then the various things from your table. So what's the probability their ears are not pierced? What's the probability they're female? That kind of thing. So using our two-way table, let's try to see if we can answer some of these questions. So to begin, B, find the probability that a randomly selected college student has pierced ears. Well, okay. That's just going to be what we just talked about. It's going to be the probability of 103 out of 178. And I am going to ask that you turn these into percentages or decimals for reasons that eventually will become clear to you. So in this case, if I find the percentage here, 103 out of 178, it should be about 57.9%. Okay? So I would like you to go ahead and see if you can try to answer parts C and D. So go ahead and pause this real quick, find those probabilities for me, and then we can resume and check your answers. Okay. So part C, it says find the probability that a randomly selected person is male and has pierced ears. Well, male and has pierced ears would be male and yes, so that would be 19. There we go, 19 out of 178, which is approximately, I should not be doing equal signs, we should be doing approximately signs, because we're rounding, which is approximately 10.7%. Okay. And then finally, we have find the probability that a randomly selected person is male or has pierced ears. And this is where we're going to get fun. So first, I will tell you the answer, and then we'll Tarantino it. We'll talk about how we get there. So the answer is 97.8%. So let's talk about how we get there. So I want the probability that a person is male or has pierced ears. And up to this point, the probability usually, that we want the probability of event A or event B. To find that, we typically add the probability of event A plus the probability of event B. However, let's sort of see what happens when we do that. So they want the probability that a person selected is male. Highlight this. So is male or has pierced ears. Okay. So what I might be tempted to do is say, okay, well, what's the probability that they're male? Well, it looks like it's 90 out of 178. So I might say, okay, 90. So 90 out of 178, that's the probability that we have a male. Plus the probability that the person has pierced ears. Well, that's 103. So we had 90 and now we have 103. So plus 103. Out of 178. That's the probability of pierced ears. Okay. And if you notice, if I add those together, I got a little bit of a problem because I end up with 193 out of 178. And of course, that's not a legitimate probability value because it's greater than 1. So the probability of something, some event A or B, I can't just add them together in this case. Let's talk about why. If you notice, when I take the probability of being male and I take the probability of ears being pierced, I'm going to count a number twice. So when I take the probability of being male, I'm counting this 19 as part of my being male because 19 of these males have their ears pierced. And the problem is, though, when I'm taking the probability of ears pierced, I'm counting this 19 again. So if you noticed, my issue with my numbers is I've counted this 19 twice. I counted it once when I found the probability of being male, and then I counted it again when I found the probability of having ears pierced. So to make up for that, what I'm going to do is I'm going to take my 193 and I'm going to subtract that one of those 19s out because I counted 19 twice. And when I do that, I should end up with 174 out of 178, which should give me 97.8%. So let's debrief for a second. I did this sort of in a little bit of a convoluted way. A lot of you guys may have done this differently. Like you might have said or figured out, okay, the probability the person is male or has pierced ears. So basically these three numbers, 19, 71, and 84, would count towards the probability that I want, and the only one that wouldn't is this 4. So you might have done something totally different here. But the reason why I did this is because of something called, that's not what I want at all. I hate you, Microsoft Word. Guys, I want you to know how much I hate Microsoft Word. Okay. So the reason why we did this is so that we could look at something called the general addition rule, which goes like this. The probability of A or B happening, A or B, probability of event A or event B, can always be found by finding the probability of event A plus the probability of event B and then subtracting the probability of anything that event A and B have in common. Before, when we did the probability of A or B and we were just able to add those two probabilities, that only counts for, remember, mutually exclusive events. And mutually exclusive events are events that cannot happen at the same time. So let's go back up to what we're asking for here. We want the probability that a randomly selected person is male or has pierced ears. Well, can you be male and have pierced ears at the same time? Yeah, of course you can. In fact, there are 19 males who do have pierced ears. So in this case, being male and having pierced ears is not mutually exclusive. which means that I can't just simply add the probability of A plus the probability of B. I'm not going to get the right answer. So this is what I did. The probability of being male or having pierced ears would just be the probability of being male. Oopsie. Probability of being male plus the probability of having pierced ears. And then, if you notice, I subtracted what they have in common. And if you notice, what they have in common is this guy, 19. Okay. So, all of that to say, this guy is the general addition rule. He's a big deal. He kind of comes up a lot. We're going to look at other examples where we need to use those. But we're going to do that using Venn diagrams and two-way tables. Okay. So two-way table, remember, they're very rarely going to give you a two-way table. So what you're going to start with is creating the table with your two variables, filling in given values, solve for unknowns, and then do your best to answer any questions that they ask you. Okay. Moving on. The Venn diagram. So we now move on to Venn diagrams. And I know in English, Venn diagrams are usually just two circles with that are overlapping. But in real math, that is not necessarily the case. So let's chat. First of all, our Venn diagram is going to consist of not just a circle, but it will consist of a circle and a rectangle. The stuff inside the circle is going to be anything that represents event A. The stuff outside of the circle and within the box is going to represent not A. So for example, if my event A was being male, then everything in the circle would represent people who are male, and everything outside of the circle would represent non-males, if that makes sense. Okay? So then let's talk about a few different possible Venn diagrams that you could have. Okay? So let's say this is event A and this is event B. This picture actually is a Venn diagram. So check it out. Discuss for a second. Pause if you need to. What does this Venn diagram seem to suggest about events A and B? Well, if you notice, there's no overlap whatsoever. So that means that an event cannot be both A and B. It is either A or it is B. So in other words, this would be a Venn diagram for if A and B are mutually exclusive. Okay, so a lot of people like Venn diagrams because they sort of visually show you what these events kind of look like together. Okay, so moving on, let's talk about what certain events do look like. So this should be fairly obvious, but we'll go with it. So what if I wanted to know in a Venn diagram, what is the event A and B? What does that look like? And by the way, symbolically, A and B is a little A and then like a frowny face, I guess. So A, frowny face, B means A and B. It's this. That's what that means. My husband says it looks like a capital A. Oh, okay. He says so you can remember it's and. That's one way to do it. I'll tell you my other way in a second. But so A and B. Next, so if I wanted to show that region that represents A and B, it's exactly what you think it is. So go ahead and shade it in right now. You can do this. Don't wait for me. Be strong. Good job, team. It's this guy. So if this is event A and this is event B, A and B is the overlap, of course. So let's chat. Well, what's this section then? What is this section that I've shaded in red? What does that represent? So discuss for a second. And then when you're done discussing, what does this section represent? Okay. Because we're going to talk about this, and then you're going to get a question wrong because everybody does. Okay. So let's talk about the red section. So what does that section represent? Well, it represents A. So everything in the red section is part of event A, but what? Well, it's part of event A, but it stops when we get to the B circle. So this would be event A and not event B. So everything in the red section represents stuff that is part of event A, but not part of event B. And then conversely, in the blue section, this represents stuff that's part of event B, but not part of event A. Okay? And then finally, what about everything left over in the box that's not part of either circle, or is that just nothing? Well, no, it's not nothing. You have event A and event B, and if your outcome is not part of either of those events, then everything left over is not A and not B. So here's what that looks like. If event A was being male and event A or event B was having ears pierced, then who's in the blue section? Who's in the overlap? Well, it's males with pierced ears. Who's in the red section then? Well, it's males who don't have their ears pierced. And then who's in the green section? Well, it's people who have their ears pierced but aren't males, so presumably it's females who have their ears pierced. Okay, so I got males without pierced ears, males with pierced ears, females with pierced ears, which means there must be another group that I'm leaving out, and there is. That would be females who also don't have their ears pierced. So non-males who do not have their ears pierced. And that would be people left out who are not part of the circle. So every Venn diagram with two circles should show 4 different areas with 4 different sort of subsections, if you will. Okay? And then finally, if you wanted to sort of see what A or B looks like, and symbolically we write that as A, U, B. So A, U, B, and A, and then that guy, B. So symbolically, A or B is written as A and a little U and B. That would basically just look like all of the circles shaded together. And then, of course, you would not shade the rectangle part because that is neither A or B. So here's how I remember which one is which. A or B, that's A and then the U and then the B. This guy I actually don't remember. That's the one I sort of ignore. A and then this guy, frowny face, and B is the one I remember. So this one is A and B. And this guy kind of looks like an N to me. So N is for and, if you will. And then the other one is or, basically. That's how I remember it. If you don't like that way, there are many other ways. But the reason why this has an N and this has a U is this U actually stands for union. So meaning I'm uniting A or B. Whereas for this guy, I'm kind of not uniting A or B. In fact, I'm really only focusing on the part where they have in common. And in fact, this guy is called intersection. So it's literally where they intersect. And the N in intersection is why you have this N type thing here. Anyway, for funsies. Okay. So now let's actually look at a problem with a Venn diagram and a two-way table, answer some questions, look at some notation, and call this a day. Okay. So go ahead and pause this and see if you can do at least part A, and then we'll talk through part B. Okay. So hopefully you got at least this far. If you didn't, a lot of people usually forget that since we're dealing with percents, we know that this should add up to a total of 100%. So hopefully once you get that, the rest of this should actually not be too bad. So it says a recent census at a major university revealed that 40% of its students mainly use Macintosh. Oh, that's the one I forgot. Mainly use Macintosh computers. The rest mainly use PCs. So there's your 40%. There we go. Okay. At the time of the census, 67% of the school students were undergraduates. The rest were graduate students. In the census, 23% of the respondents were graduate students who said they use PCs as their main computers. Suppose we select a student at random from among those who were part of a census. So part 1, they want you to make a two-way table for this chance process. So they gave you 23%, 40%, and 67%. The key is to remember, since we're dealing with percents, the total must be 100%. And then from there, you should be able to fill in the rest of the table. So for example, you know that if Mac is 40%, the rest must be 60%. You know that if you have 67% are undergrads, then the rest must be grads, so that's 33%. You should know that if we have 23% and a total of 33%, this would be 10%, making that 30%, which would make this 37%. So if you got that whole table, awesome. That is step 1. Lovely job. Okay. So just don't forget that when we're talking about percents, you can always assume that the table entirety, the total there, should be 100%. Okay. So now we go to constructing a Venn diagram to represent this setting. So they would like you to construct a Venn diagram to represent the setting. Okay. So let's do this. I'm going to start with just basically drawing the outline, if you will, of the Venn diagram. And then we're going to talk about how you can and cannot label it, because everybody messes this up every time. So first of all, I'm going to put my Venn diagram inside of a rectangle. So let's draw that rectangle. Okay. Next, I would like my Venn diagram to have some overlap. So I am going to draw 2 circles, or bulbous things, if you will. And then finally, I am going to label my 2 circles with 2 events. And to be clear, I have 4 events as options. I have graduate, undergraduate, PC, and Mac. Okay. So, my people. So you need to label these 2 circles as 2 of these 4 categories, if you will. So take a second right now and pick 2 categories in which to label these circles. And then I may or may not be mocking some of you. Okay? So pause this, label the circles. Okay. So here's the deal. You may not have labeled them the same way as I did. That's okay. But we're going to just start with this guy. I'm going to make this circle the graduate circle. This guy right here. And if I have made this the graduate circle, then the other circle must not be what? It can't be, the only thing it can't be is the undergraduate circle. Why is that? Well, if you're a graduate student, you are not an undergraduate student. And these 2 circles have overlap, which means that this cannot be the undergraduate circle because I can't have a section that's both graduate and undergraduate. So I have a choice. This second circle, and it does not matter, can either be PC or Mac. I am going to make it PC. And the reason why I chose grad and PC is actually because of the information they gave me at first. Specifically, it says in the census, 23% of the respondents were graduates who said they use PCs. Most problems you get like this will give you a percentage or a number like that that specifically hones in on one category from one variable and one category from another. And so the way I like to do this is I like to make those two categories my two circles for my Venn diagram. You don't have to though. You could just have easily had done undergrad and Mac. That could have totally been fine. The only thing you can't do is you can't make this grad and undergrad. Or conversely, you can't make this Mac and PC, because if you do, there's no overlap. Okay? Now that I have done this, I'm going to label my Venn diagram with the correct percentages. Okay? So let's talk. So the percent of overlap in the middle that I should have should be the percentage of people from this who are both graduate students and have PCs, which from the problem, they tell us that's 23%. Okay? So now I would have to fill in the rest of this. And actually, it's almost easier to make a Venn diagram after we are done with the two-way table. So let's start with the graduate circle. I have 23% of the graduate students have a PC. And so I need to label the percentage for the rest of this circle. So what should I label the rest of the grad circle? You should actually label it 10%. So if you said 33%, here's why that's wrong. This entire circle is the entire graduate circle. The entire graduate circle needs to only be 33% because that is the total for the graduates. And if I put 33 here, 33 plus 23 is not 33. So that's why this needs to be 10%. Also, think about it. The rest of this circle from this section represents graduate students who do not have a PC. And so that would be graduate students who have a Mac, which is 10%. Okay? So by that same token, for the rest of my PC circle, be careful, what should that be? Well, it should be 37%. Okay? So I should have 23 and 37% for a total of 60% for my PC. Now, if you notice, that's 1, 2, 3 percentages, but there are 4 types of categories. You can either be grad and PC, you could be grad and not PC, PC and not grad, and then our last option is neither graduate or a PC user. And so neither graduate or a PC user would be an undergrad who is a Mac user. And so that would be 30%. And so altogether, this would be my total Venn diagram. That would be how I would label it. Now, I'm not a huge fan of the Venn diagram because, as you noticed, I used the two-way table to make the Venn diagram. And the deal is, guys, if you've made a two-way table, you don't need to make a Venn diagram. Now, some people don't agree with me. Some people like the Venn diagram because it's visual. It sort of shows the grad PC visually what it looks like to have overlap. It shows what it would look like for the percentage who is not grad or PC. Totally fine, obviously, because we're looking at it. But just to clarify, kind of notation-wise, so PC and graduate would be the section in the middle, 23%. PC and not graduate would be this guy, 37%. Not PC and graduate would be this guy, my 10%. And not PC and not graduate would be everything that's not in the circle. Okay? So, we have constructed a Venn diagram. We've made a two-way table. They now are going to ask you 2 different questions about your Venn diagram and stuff you just made. So, consider the event that a randomly selected student is a graduate student and uses a Mac. Write this event in symbolic form on your Venn diagram in part B, or from your Venn diagram. So they want an event that the selected student is a graduate student and uses a Mac. So take a second, write that in symbolic form. So I have grad and uses a Mac. Well, time out. If you put Mac, that's no good because our two variables we used were Mac and PC. And so you can't use Mac because Mac is not a variable we chose. So you would have to use a different way to talk about a Mac. So you'd have to say PC complement. So not PC. If it's not a PC, then from our definition here, it is a Mac. Okay. And then finally, last part here. Oopsie. I don't know why that zoomed way out. And then finally, our last question. We'll scroll down after I punch Microsoft Word in the face. So your last question is they would like you to find the probability of the event that you described in Part C. Okay, so they would like you to find the probability of being a grad student and not using PC. So now that you've made your Venn diagram and have your two-way table, you have a couple different ways to do this. And also because we're talking percents, they just want an answer in percent. So take a second right now, go ahead and find the probability that a person, a randomly selected person, is a graduate student who does not use a PC, or in other words, a graduate student who uses a Mac. And it should just be 10%. So again, if you're not sure how to get to that, you could look at your Venn diagram and say, okay, I have graduate and not PC. That must be this 10%. So 10% it is. Or you could look up at your two-way table and find graduate and Mac, and there's the guy you want. You're done. Okay. So you have created a two-way table. You now know how to construct a Venn diagram. But when it comes to actual probability problems and finding answers, you can actually use either one. They are interchangeable. So you can totally make a two-way table and only use that, never touch a Venn diagram, totally okay. Or you can make Venn diagrams every time and never make a two-way table. Totally up to you. All right, people, you hung in there. Well, hopefully, I assume. I don't really know. That being said, have a lovely day.